Okay, here we go again after a long, crazy day today. Let's go ahead and go through the examples once again, but this time with everything correct and all clear. You can pause it as it goes along so that you can make sure you get it all and you understand it. And then, of course, come and ask me questions on Monday if you need it. Okay, so here's our standard form of an equation. Okay, we have the con, which is written right here. Some of the smartboard stuff got moved when I opened this in the app. But this is the con. So when I look at this, I can't say, oh, look, there's this shift up, shift down, shift left, shift right. Okay, the only one that I can see is the vertical flip, which just like on the vertical form that we did last class would be located out here in front with a plus or a minus sign. Well, of course we wouldn't put the plus, but with the negative on the front. The reason we use this is because we can find what are called the roots. Roots are just a fancy word for x-intercept, and it's really important in math. You may not think this, but really understanding the vocabulary and making sure you get that memorized, because it's the meaning of these words that take us to the steps we do next in the problem. Okay, and that's going to be the case with x-intercepts, as we'll see here in a second. So let's try some examples. Okay, so this is ours. That is supposed to be the x squared, but the superscript looks like it messed up when the app opened it up. So we have x squared, y equals x squared minus 4x minus 12. Now, we have 3 steps on these problems. I'll just put them across the top. First, we need to find our roots by factoring. Looks like my stylus doesn't want to work. Then second, we've got to find our vertex, but it's a 2-part thing. So we'll start by finding the x coordinate of vertex, and then the third step will be to find the y coordinate of the vertex. Okay, so that's the roadmap for what we're going to do. So we're going to start off by finding the roots. Now, how do we know we're going to be factoring on this? This goes back to our definitions. So roots literally is just a fancy word for, that doesn't want to work, the x-intercepts. Okay, now what an x-intercept is any point on your line, curve, parabola, circle, whatever, that's along this, the x-axis. It's intercepting, if you're using football terminology, it's intercepting the x-axis or running into it. Now, if we wanted to, we could plot out every single point on the x-axis, and you're going to see a pattern really quick as we do this. And what we see is this point is 1, 0, the next one is 2, 0, the next one's 3, 0, 4, 0, negative 1, 0, 0, 0, negative 2, 0, going right and going left. The clear pattern is that every y coordinate is 0. Why? Why is that the case? Well, if it is an x-intercept, that means it is landing on this line, like we've already established, and the only height, meaning y-coordinate, because we said every single x-coordinate has a 0 for the second number. The first number is wherever it is on the x-axis, left or right. The y-axis is the second one. Any x-intercept will have a number for the first one and 0 for the second, because the only height vertically, up or down, that you can be at and be located on this is 0. Okay, now you might be like, why is she going through all that? Because if you know that the y-coordinate has to equal 0 for your x-intercept, and you're wanting to find what numbers or x-coordinates those x-intercepts are, since we would already know the y-coordinates for each of our roots or x-intercepts is 0, we use that information in our equation, the pattern that describes this parabola. So we say, okay, well, we want to know the x-intercept, which means y is equal to 0. It has to be at a height of 0 on this pattern. And so we plug that in. Okay, and that's what we get. This is an equation. We now have just a single variable of x. It happens to be in a quadratic form with a square and then a singular. Okay, but that's our clue. Oh yeah, we should probably factor it. So on this, we're going through the questions, whether it's chubby cheeks or any other method you choose to use. Okay, but when you go through that, you're going to get x minus 6 times the quantity x plus 2. Okay, if you don't know where I got those, go try your chubby cheeks, or go try your AC method, whatever method your teacher uses. The basic idea is you need two numbers that multiply together to equal negative 12 and add together to equal negative 4. Okay, so coming from this point, I'll make that more of a parentheses, we know from our zero product rule that if you have two numbers being multiplied together and they equal 0, then at least one of them, whether it's the first one or the second one, or both, have to equal 0. When we solve these, we get x equals 6 or x equals negative 2. What this means is that our roots are at x coordinate 6, y coordinate, I hope you thought 0 in your brain and wondered why I paused, because we already talked about it, and then 2, 0. So I can go to that on my graph. 1, 2, 3, 4, 5, 6, and then 1, 2. Okay, and those guys are my roots. Okay, so part 1 taken care of. Now, the only other thing we need to find is the vertex to give us our third point that lets us do the quick but accurate sketch. Vertex is made up of two coordinates. We have the x-coordinate and the y-coordinate. Now, we start with the x-coordinate because this really cool thing about parabolas exists, and that is that they are perfectly symmetrical. Okay, horizontally they're symmetrical, which means if we found somewhere to fold along, okay, one of them is going to have to be exactly in the middle of the parabola so that when we fold along it, our two roots actually line up perfectly with each other. So the question is, or becomes, where's the middle of this point and that point? Okay, and where is the exact middle between those? Now on this one, it's one where you could count, but let's say if it's one that you didn't have a graph. Back from geometry, we got a midpoint formula for x's and y coordinates. On these, we're not going to worry about the y coordinate because we just want to know where the x coordinate is. Why? Well, we know that if it had the exact same y coordinate as these guys, okay, and it was perfectly in the middle of these two, is that a parabola? Oh, that's a line. So that's why we're not worried about the y coordinate with our midpoint formula, because that wouldn't make sense for a quadratic. And we know if it has this squared, it has to be a parabola shape. Okay, so our midpoint formula is x1 plus x2 divided by 2, or in other words, the average of the two numbers you're trying to find the middle of. So on this problem, we have negative 2 plus 6 over 2. Negative 2 plus 6 is 4, which is still over the 2. 4 divided by 2 is 2. Okay, so this 2 tells us two things. This is the x coordinate of the vertex, And the reason we know that is because it's also the location or where the axis of symmetry is. Okay? So where x equals 2, and every single coordinate that has a 2 in the x coordinate, in the x position, is going to be located along our axis of symmetry, which I'm tracing right now. And visually, if you were to look at that, you can see, oh yeah, that would definitely be the middle. Okay, we now know that our vertex has to be somewhere on this, and again, the reason for that is our vertex needs to be perfectly symmetrical. So we know so far that to finish this off and get our third point, which is our vertex, we know that the x-coordinate has to be 2. Our last question to ask ourselves and find out is what's the y-coordinate? Okay, well, we're using the same reasoning as we did on this part here. On this part, we knew we wanted the y-coordinate to be 0, and we wanted to find which x coordinates match up with 0 for this pattern that's been given to us. Doing the same thing, only this time we know what the x-coordinate is, but we want to find the y-coordinate. I'm going to squeeze it in right here, because if I change the slide, it'll stop recording. So we have y is what we're looking for, and we're saying, okay, well, our x-coordinate needs to be 2 for it to be in the middle, which is where our vertex is along the axis of symmetry. Minus 4 times 2 minus 12. Y equals 4 minus 8 minus 12. Y equals negative 16. So, by plugging one coordinate of a pattern into, one coordinate into our equation, we can then go back and find what the other one is that would work with it. So if I count by 2's on this, I'd have 2, 4, 6, 8, 12, 14, 16 right there, and 2, which means I'm now ready to complete my parabola, which I'm just going to put an arrow right there, just because it's going to go through that. So our vertex is at 216, to negative 16, okay, giving us this. Now the only one of our shortcuts, or not shortcuts, but graphing secrets we can actually see that is happening is that the coefficient, or at the very front of this, it's not negative, it's positive, which means it's going to be opening up. If that had been negative out in front, we would have known and been able to check our answer and said, oh yeah, it has to be going down. So if you're doing this and you mess up with your positives and negatives, on standard form you can at least avoid that mistake right there by accidentally messing up and thinking your answer is, positive 16 and putting a dot up here. Okay, because then if you looked at that and you're like, wait a second, that's going to go down, but this was a positive number here, that doesn't make sense, and you can avoid a little mistake. Okay, here's the page I was going to work with, but I did it all. Let's do one more and make sure we're all right. Once again, this 2, for some reason when I open the PowerPoint in this app, it doesn't like the superscript, so that should be x squared plus 16x plus 39. Okay, same process. I'd like you to pause or make sure you understand what's going on. Maybe try it out on your own and then push play and check each part as I go through it. We're going to follow the same steps though. We're going to find our roots, then we're going to find the x coordinate of the vertex, and then 3, we're going to find the y coordinate of the vertex. Okay. Okay, so roots. What are the roots? Roots are just a fancy name for those x-intercepts. And if it's an x-intercept, we know for sure that the y-coordinate has to equal 0, which means when I take this equation down here, I will plug 0 in for y, which will make it so that our point is exactly along this line somewhere. We just need to find where. Okay, is equal to x squared plus 16x plus 39. Okay, so on our factoring here, we're trying to find two numbers that multiply together to equal 39 and add together to equal 16. So when we continue on here, we have 0 is equal to, and you can pause it and do your chubby cheeks or whichever method you've learned, and then check your answer. Okay, so I know 13 times 3. Positive 13, positive 3 gives me positive 39 when I multiply them, and then positive 13 plus positive 3 is equal to positive 16. So that works. Now, thanks to our zero product rule, one of these guys, or both of them, have to equal 0 if when you multiply them all together, their product is 0. Okay, be careful on your roots. You might get tempted to do stuff in your head and say, oh yeah, when I factor I get 13 and 3 and those are my roots. When that is not the case, because as you see here, when I solve for x turns out to be negative 13 and or negative 3. Okay, so when I put this on here, I'm going to count by 2's. So if that's negative 2 right there, this would be negative 3 in the middle. Okay, so we have 2, 4, 6, 8, 10, 12, 14, which means 13's in the middle. I'm going to make a note that that's 14. Okay, part 1 is taken care of. Part 2, x-coordinate of the vertex. Vertex is located on the axis of symmetry. Axis of symmetry will be perfectly centered between these two. You can use the midpoint formula, which is x1 plus, oops, I put 14 because I saw that label on my graph. That might be a good reason to label every number on there, especially if you're on a quiz. Negative 13 plus negative 3, x1 plus x2, all divided by 2. Come down over here, we get negative 16 over 2, which is equal to negative 8. So when we look at our picture, we have 2, 4, 6, 8. So right here, this is where we could fold this parabola right down the middle. Okay. Our vertex has to be located on the axis of symmetry, which means we know it has to have a coordinate of an x-coordinate of negative 8. So using our same reasoning we did up here with the roots, instead of plugging in a 0 for x, this time we're going to plug in the one that we have, which is negative 8. Oops, instead of plugging a 0 in for y, okay, we're going to take what we know this time, which is x is negative 8, if we want the vertex, and plug that in for x. And once again, I'm going to squeeze this on here. So this is going to be y coordinate. So we don't know what y is, we're looking for that, but we do know that plus 39. We do know that x is negative 8 if we want the vertex, because that's on the axis of symmetry. So we get y equals 64 plus negative 125 or minus 125 plus 39. So then y is equal to negative 25. Okay, so our vertex then is at negative 8, the x-coordinate we found the axis of symmetry is on, and that we plugged in, and then negative 25. I'm going to go ahead and count by 5's, 10, 15, 20, 25. And so here we have our vertex, which means then our axis of symmetry, our parabola is going to be right there. Okay, well, I hope that makes a lot more sense. Let me show you the assignment. I did cut some problems off from what you saw at the beginning of the day on Friday. Just as oh, that was the work page. Okay, so again, make sure your vertex is clearly labeled. So put in your coordinates like I've been writing. Write it near your graph though, so as you're checking it's right there. Okay, so that needs to be clear. And then your roots are clearly labeled. I didn't do such a great job because I was running out of space with this stylus. Okay, but your roots should be clearly labeled because you're labeling, you know, your x-axis, -1, -2, -3, -4, -5, which means you have this, you know, and so we can see where the roots are. Graph paper is required. It will not be graded if it's not on graph paper because I don't want your graphs looking like this. Ugh. Okay, so your assignment. Again, remember all these 2's after the x's, those are supposed to be squared. The dumb app. But it's not too dumb because it's making this possible. Okay, so those guys are squared. A couple of things. When you're doing your factoring, I have picked problems that give you nice factors, meaning whole numbers, with the exception of this one. Okay, but those guys are nice fractions, meaning you're not getting crazy numbers like 11 over 21 or 45 over 10 or anything like that. Okay, but they are fractions. Don't be scared of them. They're just numbers. They're numbers too. Okay. After that, I just noticed the numbering looks weird. So that's number 1, that's number 2, 3, 4, 5, 6. The thing I want to warn you of, though, and I'm trying to be better at this and do it on purpose, and not feel guilty for giving you ones that don't give you nice numbers. Life is made up of ugly fractions and ugly numbers. Okay, you need to become comfortable with them. Annoyed with them, that's okay. Comfortable, not scared of them, okay. That's what we want. Why do I say that? There is no guarantee that when you go to find your vertex, x coordinate, and like on number 1, especially the y coordinate, there's no guarantee that those are going to be nice whole numbers. Does that mean you can't graph it? Of course it doesn't. You can graph it. Okay? Now, what I would suggest, you know, when we saw our other ones and you had lots of things, everything's over 2, they're all versions of halves, then you can just change your x-axis and count by halves. But let's say your roots turned out to be like, I don't know, 6 and then positive 12, and then you have your midpoint here at, I don't know, 9. Hopefully you got that. Okay. Let's say you plug in that 9 and you get an answer of negative 21/35. Nope, those are both divisible by 7, so I'm going to go 36. So that, we'll assume that that's also factorable. 21, not 33rds, 37ths, we'll go with something prime. Okay, do I expect you to be able to graph that? Yes. Okay, do I expect you to spread out what you're counting by and count by 1/37, 2/37, 3/37, 4/37? No. Okay, so with these crazy things, okay, if you aren't sure how to get it onto the graph, and it's something where you're like, she probably doesn't want me to graph counting by 37ths, your other option to get a good estimate, an accurate thing, is to change it to a decimal and then estimate where that's at. Okay, so for on this one, if we change that to a decimal, we'd have negative 21 divided by 37, and we get 0.56. We'll go 0.57 with our rounding. So the next number was a 7. Okay, we get 0.57, so that's a little bit over 1/2 in the negative direction. Okay, and so that's where you'd put it. What label would you put on it? when I say to label your vertex, you'd give the most accurate label. Okay, we're just going to use the decimal to estimate where to put it on the actual graph to make our lives easier. Okay, come in, see me Monday. I do have a meeting right after school for about 15 minutes, but then I'll be back. Tuesday I'll be there. I am changing my day that I'm hanging out until 3 o'clock and working with you guys to Tuesdays because I'm doing some other tutoring along with that. So yeah, good luck, get some sleep, enjoy your weekend, relax, and we'll see you on Tuesday.